We want to use the unit circle drawn here to estimate the values of the following. Now, if we recall our work with the unit circle before, if we have an angle, say here, then we refer to the right angled triangle just here. So if this is x and this is y, and remember we always take a unit circle, so the radius is 1, this distance is x, this distance is y. So the sine is the opposite over the hypotenuse, so the sine is always going to be y, and the cosine is adjacent over hypotenuse, so that's always going to be the x. So over here, the sine of 0.4, since this distance is 0.92 and this one is 0.39, the sine is just going to be 0.39. The cosine of 0.4 will be 0.92. Now the tan of the angle is always the opposite over the adjacent. So for tan of 0.4, we get y over x, which in this case is 0.39 over 0.92. So let's work that one out. So 0.39 over 0.92, so about 0.42. Now in part D we have the sine of 2.74. So whereabouts is that? Well, if we do pi take away 0.4, that's about 2.74. So what we're talking about is this angle just here, where this is 0.4. So the sine of 2.74 is going to be equal to the sine of 0.4. Remember, this is the S quadrant, so the sine is positive. So that's going to be 0.39. Then we want cos of 5.88. Well, where is that? If we do 2 times pi, we get this. Take away 0.4, and that's our 5.88. So that's actually going to be down here. So the angle we're after is this one, but the associated acute angle is this one. And this is the C quadrant, so once again the cosine is positive here. So that's going to be the same as the cos of 0.4, and that will be 0.92.